I will continue to talk about logical operations in this video. We've already seen an example of the logical operator precedence. So here's a little more detail. As it turns out, among the three logical operators, not has the highest precedence over and or. But then and actually has a higher precedence than or. So if we look at an example, true and not false. So the not false gets evaluated first. So that becomes true. So true and true means it's true. That shouldn't be too surprised, but this one may get some of you sometimes. Is that if we actually say true or true and false, what gets evaluated first is true and false. That gives you false. So true or false is true. Okay. So if the precedence isn't like that, if n doesn't have a precedence over or, then the expression would be evaluated like this. It will evaluate the or first, and true or true is true, and then true and false would be false. So yeah, you can contrast the two results, and that's a proof that actually and has precedence over false. And for those of you who are a little confused with what I just said, I mean, I said true, false, false, true. Gosh, you're probably like, where are we going with this? Well, I mean, I know it can be a little abstract, a little confusing at times. Just take a deep breath, go through it step by step. And again, practice makes perfect. If you do enough of these, it should eventually click. Okay, one more thing about operator precedence in general. As it turns out, and you might have kind of noticed this when I was writing my code, things like hour less than 0, that actually takes precedence over the logical operators, right? So for another example, hour greater than 24, that's evaluated before the logical operators. So what it is the arithmetic operators such as plus, minus, multiply, division. That has precedence over the relational operators such as equal, less than, greater than, etc. I think in my other video I call these comparison operators. Well, that's not wrong. I think the more formal name is these are relational operators. Okay, and both of these have precedence over logical operators that we just learned, which are the nots, the ands, and the ors. And when things are not obvious or when things are confusing, just use parentheses. That should help you to clear things up. Okay, so I think it's time for you to do a little bit of exercise as well. So here are a bunch of expressions. You should just by hand on a piece of paper try to evaluate all of them to see if they come out to be true or false. Okay, and once you do that, you can try to verify with the computer within your Python interpreter, or after the pause, I'll show you what they are. Okay, so hopefully you've done this by hand, and here are the answers that I came up with. So hopefully yours match mine, and if they don't, go back um, and try to redo them. And if I make a mistake, please let me know. And then change the x to a different number and do this whole thing again and make sure you still get it right. For this, I don't have the answer key, but you can easily obtain that by doing these things in your Python interpreter. Okay, so one more thing that I like to show you is that remember our original one was that if the hour is not between 0 and 24, then that's not good, right? So let me make sure it still works. So this still works. Now, as it turns out that this kind of range checking is so common that Python allows you to have a shorthand. You can actually do this thing, which is actually more intuitive, and this is probably something you will write in math class, that you want to make sure hour is literally between 0 and 24 inclusive. So this is something that Python allows you to do, and as far as I know, C++ or Java do not allow you to do this. So let's run this and make sure it still works. We say 5, it still works, and then if I say 100, that's outside of the range, and there, it complains. Okay, that's what this slide says. And oh boy, okay, one more topic. And now, what if we want to check something like, okay, given a number, is it 1, 2, or 3? Okay, you might just type code like this. Okay, I type a number, and is number equal to 1 or 2 or 3? Well, if it's one of those, we say it's good, otherwise it's bad. Okay, so let's run this. We say 1. Okay, 1 is good, right? One of the 3 numbers that we expect. Let's do this again. I'm going to type 10. It says it's still good, even though it's not one of the 3 numbers we expect. Why is that? So the right way to write this is you have to check the number every single time. We have to say that the number is the number 1. And then you say, or if number is 2, or finally if the number is 3. So every single time in these operands or clauses of the OR operator, you have to explicitly say, I'm checking against the variable number. So here, hopefully now it works. If I type the number 10 doesn't equal to any of these numbers, so all of these are false, and now it tells me that it's bad. Still, it begs the question, why the original code that we wrote, why does it work, and work in the sense that it runs, and why does it tell us it's good when we put in 10? It's something fairly interesting. As it turns out, the reason is that every type in Python, these can be converted to bool. And that is actually true in C and C++, but not true in Java. Java really hates this, so they got rid of it. What I mean by that is you can convert any expression into a Boolean expression, into a Boolean type, any expression or any value of any type into a Boolean value. And you do that by, just like when you want to convert something to an integer, you say bool and then that expression or value. Okay, and you can do this with pretty much anything. And then Python has its own little rule that decides what gets converted into false and what gets converted into true. For numbers, let me just run this. For numbers, the only number that is false is the number 0. All the other numbers are true. Okay? Yeah. Not positive, negative, whatever. They are all true. The only number that is false is 0. What about string? For string, run this. The only string that is false is an empty string. Any non-empty string is true. And I think, yeah, that's basically what I stated here. You should try to verify that and try to figure out for float, which float is considered false and which float is considered true. And I think it's probably pretty obvious, but give it a try. So that explained what happened in this piece of code, right? In the in this condition, in this OR operation, it sees a number 2, and because it's in an OR operation, it wants either true or false. So it tries to convert 2 into a Boolean, and 2, because it's not 0, it is true, and so is 3, and therefore, you know, this is true. So in an OR operation, this whole thing is just true. So it really doesn't matter what you type for your number, because there are two truths here. It's always going to print out that it's a good number. That's what happened. Okay, so why does Python allows something like this? So I mean, there are reasons. May or may not be a good reason, depending on your perspective. But it allows you to write some code like this. Let's say I have, you know, a variable that's represent the amount of money that I have, right? And then I say if money, then I say I can buy things, right? The if money kind of reads like, you know, if I have money. So in that sense, it's kind of it sort of makes sense and it's sort of readable, right? This piece of code, if I have money, is the same. It's the same as saying if money is not 0. So these two pieces of code do exactly the same thing. Arguably, they are probably about as readable as the other one. But again, depending on your experience, depending on your perspective, you may prefer one or the other. As beginning programmers that most of you are probably in this class, I know some of you have a lot more experience, but for those who are just starting to learn programming, I believe doing the explicit comparison in this particular like this, doing the explicit comparison is probably the preferred way to go. Okay, but again, these two do exactly the same thing. All right, so having spent all this time talking about and or not and all that, so I will leave it to you to complete our time program. So again, your time program should ask for the hour, between 0 and 24, a minute between 0 and 24, and a second. The second should be a float that's between 0.0 and 60.0. And then once you have those three pieces of information, you should print it out in the format like this, right? One thing to note is that if the minute is say 5, we want a 0 in the front because that's how you typically see time. And if you have trouble with that, that's understandable because that's something we'll cover next. But go ahead and at least complete this, this program as much as you can. That's the end of this video.